Another quick definition that is an operator on two sets is what we might call the subtraction operator. For sets A and B, this slash symbol is used in our book. I really prefer, and I think people are starting to use more, just the minus sign. This is set subtraction, that symbol is. So you may see either one, they mean the same thing. And I'm going to write this out in two different ways. It's a set of all x such that x is in A and x is not in B. So essentially you start with the elements in A, and one by one you remove every element that happens to be in B. Another way, I think it's every bit as clear, as I could have just said the set of all x that is in A such that x is not in B. They mean exactly the same thing, they're equivalent. I probably prefer the second one. It simplifies the right-hand side after the such that part. This is, in words, called the complement of B relative to A. I will rarely use that phrase or that expression, but I will frequently say A minus B or B minus A. So a real simple example, we'll take the set A being the numbers from 1 to 10. And B will be the numbers from 3, 4, all the way up to 99. Well, let's just do it both directions. What is A minus B? It's simply the elements 1 through 10, and then remove 3 through 99. We'll notice a lot of these elements aren't in there, and you can just ignore those. So the only ones we're going to remove would be 3, 4, 5, 6, 7, 8, 9, 10. So A minus B would simply be the two elements 1 and 2. And let's do B minus A. B has a lot more elements in it. We're going to start with 3 through 99, and we're going to remove 1 through 10 from that. Well, notice 1 and 2 are not in that set, so that you don't do anything with those. But we are going to remove 3 through 10, so it's going to start 11, 12, up to 99, like so. Now let's take a look at a theorem we'll call theorem 0.3. Fairly short theorem. We're going to take 3 sets, though, in theorem 0.3. If A, B, and C are sets, then the following 2 statements hold. I. The first one, A minus B intersection C in parentheses, B intersection C in parentheses. Well, if you think back to that distributive law, it's going to look a little bit different. We're going to do A minus B, and we're also going to have an A minus C, but I'm going to flip that upside down. That's equal to A minus B union A minus C. And the second one, similar, it's going to be A minus the union of the 2 sets, B and C. And you can probably figure out what it's going to look like. It's going to look just like this right-hand side, only we're going to flip that union into an intersection. This union gets flipped into an intersection. That's theorem 0.3, and we'll talk a little bit more about that.